Hey, it's Brian here from quantlabs.net. I just wanted to show you what I think is a pretty pivotal post on my blog, which is really important. And I'm starting to think to go down this path as opposed to traditional means of doing strategy development, numerical analysis. First, let me just highlight two webinars here. There's this one, and then there's this one. This one is basically how to develop symbolic math, or use symbolic analysis versus numerical analysis. And the other one is how to use the Symbolic Math Toolbox to develop and analyze financial models. Now, before I get any deeper, after watching and being part of Ernie Chan's video or webinar yesterday, I've come away with a couple of conclusions because I'm trying to optimize my strategy development for more complicated trading algorithms. This right here, this webinar, and I've included all my notes. You can see that it's symbolic computation versus something called numeric analysis. So what we're doing here is we're using this Matlab Symbolic Math Toolbox, and basically what you're doing is you are using MuPad as part of that process, which I showed last week in how to develop your algorithms or computations symbolically. So there's a lot of advantages doing that way as opposed to numeric analysis. So what's the difference? So if you're using, let's say, R or Python, you're at a disadvantage because you're always working with real-world data, and you always have to pre-populate your matrices and vectors with data. Using this toolbox, or the Symbolic Math Toolbox, enables you to be a lot more precise in how you are building your algorithms, and you're as I said, you're symbolically building it. You're not doing it numerically and then running a test and iteratively changing the data to get it to a certain level. Here, you're able to symbolically work on your algorithm or calculation using basically your formulas, and you use the MATLAB to build that. So you can build that interactively, and on top of that, you're able to develop some nice, basically some documents from that. And not only that, but you can also include plots, 3D plots, 2D plots. I'm going to show you through the notes on that, and some other really cool stuff. From there, because of this toolbox, you can tightly integrate it between MuPad and your M script. So you can then basically take your M script and then deploy it into something like, let's say, into Simulink for a more advanced model from within Simulink, or you can generate C code right from the function or the MATLAB M function itself. So let me go through the notes here in the first webinar. Now again, this is using symbolic computations to develop efficient algorithms and system models. There's two big advantages with this, is that you can get more precision with it because you're using fractional versus flotation representation. And on top of that, you're able to see how the data flows and how the numbers and your variables interact with each other when you do it this way. It's very powerful. And this webinar walks you through that entire process, and it also gives you a advantage over numerical analysis. So I think at the same time you can essentially work on your backtesting as part of this analysis. So you're saving yourself a lot of time. So essentially the big benefit of using numeric versus symbolic, if you use symbolic, the one example he's got, he's able to prove that you're able to speed up your development time and your testing by over 1,700%. And he's also using a bond pricing example as well, and he's also using demonstrating yield curves with the bond pricing. And then there's the ability here this time to be able to import it from an Excel spreadsheet. And then he also shows how to interact between MU, the MuPad language, and the M scripts. And there's also a demo of it and how you can do it with plots. Now, he also goes into greater detail, this presenter goes into greater detail on the huge speed improvements that you get with symbolic analysis versus numeric. And again, to me, I'm not an expert at this. I'm not a PhD or not even a master's level. When you do this type of analysis, you're doing the same thing as backtesting. But I'm clearly seeing the huge advantages, not only in the rapid development on your algorithm itself, and that, again, that can be from your research paper or wherever, even in your head where you might have it in some kind of symbolic notation, and then be able to get it banged out a lot faster. Because again, when you're doing this numerical way, it's the same as just doing it via backtesting, and this way with a symbolic analysis is much, much faster. Now, I asked, where does that leave R and Python development? And I'm going to show you some links further on after the notes here in the second webinar. So going back to the second webinar, what we're doing is we're using Matlab and Symbolic Math Toolbox to develop and analyze financial models. So it is specific to advanced financial models. So let's go to the notes here. So if you've been following me for a while, I can tell you from what I saw at this point, this right here is what I saw from the most successful quant trader or researcher that I've seen over the last 3 years. I'm not going to say who it is, but it's the most successful and the most profitable. And I know it's very similar, but the end result is exactly what this person's using. Okay, so that's another big advantage. At this time, 429, it gives you the insight of the math. So yeah, basically, if you're using symbolic, it gives you, as I said, the insight of using the math versus just using some whatever generic financial toolbox function or the econometrics toolbox function. So, and as I said earlier, you can understand the interaction of variables and the impact on those results. And you can see it instantly as you change the data. Because you can, within your MuPad, you can instantly change the values of those variables. You can do it interactively. You can also solve the problem once you solve numerically, but as I said, if you solve numerically, it's a slow iterative approach, because basically what you're doing is you have to start over again with a new approach and recompute everything. But with a symbolic, you're not doing that. You're doing that on the fly in session, and you're not having to restart everything. So basically, a lot of the models that you see in advanced research papers are basically expressed analytically. Symbolic math can be applied because of this. And then from there, because you express it this way symbolically, you can then use them as building blocks to create your own custom models. Now, this time here in the second webinar, he explains how you go from the symbols of the MuPad to the numeric analysis, basically your Matlab iterative environment within the workspace of Matlab itself. Because remember, in MuPad and Matlab, they're two separate environments, but you can easily connect the two with some functions. I've actually demoed that in past videos. Now, this is something I didn't know from MuPad. You can use this to create symbolic functions. And he shows you how to do that. And then you can make generic or general expressions as functions as well. And then apparently, within the Notepad editor, there's also a MuPad editor where you can create your own custom MuPad procedures. And there's also an entire library of functions that are available as part of the MuPad language. Okay, so at this time, he shows you some 3D plots, how to animate. So that's all part of MuPad. And then he also shows you how you can create these text regions and Notepad and put them into your notebook document. And again, you can easily connect the MATLAB M script with your MuPad notebook document. I was just impressed with that. Now, if you're new at like I am, at this time, 2750, he introduces the different ways to optimize the algorithm, and there's different optimizers that you can use and solvers you can use. It's part of the optimization toolbox. Now here, let me just blow this up. These are the available Symbolic Math Toolbox libraries. So these are part of the MuPad library. So it includes all your algebraic, limits, Taylor, Jacobian, differentiation, Fourier, Laplace, Z transformation, and a bunch of other stuff, plus your graphing and your animation. So it includes all the major stuff as well that you would expect to see. Maybe some other stuff, but again, you can somewhat develop your own custom libraries or functions or procedures, as they call it, whatever you want to call it. So there are a lot of advantages with this, using the Symbolic Math Toolbox. Now, I never knew about it until I started digging into it via these two webinars. On top of that, like I said, I thought to myself, where is R and Python in relation to all this? Now, when I looked up R, and this is today the 1st of May, man, I'll tell you it's very limited in the world of R. There's only this project here, RYACAS. There's this vignette. You check that link. It's very limited. It's not going to give you the GUI, the Notepad editor as well, where you can bang out your ideas really fast. It's all command line driven through this R package, so it's really limited. So my opinion, that Notepad editor functionality, basically the MuPad, gives and makes MATLAB light years ahead of R. Okay. Now, I'm not an expert in Python, so I thought I'd take a look at this one, the SYMPY or SymPy, I guess it's called. And then just one big thing that really surprised me is just the open-ended issues. There's quite a bit. And that's one of the reasons why I don't really venture into the world of Python, because of this. You know, why should I go through that pain versus using something like this Symbolic Math Toolbox? Now, when I check the pricing of it, it's $1,000. So, considering this for $1,000 versus all this with our Python and the amount of time you'll save, and the other reasons I've already stated, that $1,000 might go a lot further than you could think. All right. So that brings me to my third webinar, and I've got some notes on that as well. Now, this is an older webinar. It's basically generating C code from MATLAB functions using embedded MATLAB subset. So there's no difference when this is embedded subset. This is the older embedded C compiler, I guess it is, which is part of MATLAB 2009. Now, it's going to use all these old functions, but I have verified the MATLAB coder is more updated than what I saw. So all the functionality you see in here, there should be equivalent in the MATLAB coder. So essentially, the notes I took away from this third webinar is it generates a Kalman filter. Like, hey, I've seen that in a number of quant algorithms. Generate C, and then you apply the algorithm and put it into a Simulink for what they call system level modeling. So in this essence, it's no different as if you were to have a data source and then have it, let's say with Stateflow, build trading signals and then be able to send back some sort of trading signal to have your trading platform basically do an entry or an exit. So with that in mind, when you figure it out, if I'm going to work with just C, I mean, I could use C++ if I really want to, but why bother? the object-oriented programming was generated, just confuses you even further. Let alone if I wanted to go the FPGA route for ultra lowest latency for high frequency trading, you would definitely want to stick with C. And C for simplistic reasons. C++ just adds a lot more complexity with the object-oriented. So I would prefer to do things in C. But anyways, so let's say we focus on C. One thing I took away at this point is you can deploy the same workflow and put this into assembler. That's the lowest representation you can get to on the processor. So you don't get faster than that. Now he's also explaining if you were to basically take something from MATLAB and hand code it in C or C++, a lot of disadvantages. It's going to be obviously prone to errors. It's not scalable. Plus, because you're working with an intuitive environment of MATLAB, you get all the other advantages of visualization and other MATLAB features that are pretty well limitless. So he introduces the workflow at this point right here, 10:08. So as I said, the newer, because this webinar is from 2009 version B MATLAB, but I do think with the newer versions it's in the same functionalities in MATLAB Coder. As I said, he explains the MATLAB M function. He's not using the Kalman function. He's actually hand coded his own algorithm for Kalman, so he walks you through that. And basically what he's doing is, with a Kalman filter, I mean just alone I wouldn't do it, but you could track price movements and estimate direction of those movements. And that's sort of demoed in this webinar here at this time, 1901. But as I said, it's just a filter that you can apply on top of another algorithm. It's a filter. All right, so he also explains here at this time at 3239 how you can use C or generate your own C, and you can basically generate C that's dynamic to your function. So it's not fixed on the bounds of the data limits of your vector size or whatever, your matrix size. And as part of that, you're also generating a DLL as well. Okay. Now this is very fascinating because I never knew about this, but this is what I picked away from here. We all know when you're using MATLAB Coder, let's say, there is a way to turn off all the functions that are not supported for the MATLAB Coder or code generation process. There's a way you can turn those off, and he shows that in the demo or the webinar. It's basically intrinsic, that you make certain functions that are part of the MATLAB M functions, make them intrinsic, which means they're not part of the coding generation process. All right, so he goes on about the code generation C, how you can get it faster as opposed to just generating a MEX file. That's pretty obvious. He also, at this time at 49 minutes, explains the changing the input size, that dimension that you're using on your matrix. You can generate C from that. Here's the exact function to do with that, or how to use that is with this function right here. Now the other thing that I find is complicated. Now this is for when you decide to go the FPGA route. You have to use fixed point, and he's got a whole whack load of stuff on how to do that. And then he's got a function that he built, a MATLAB function, this global fixed point math function that helps get through that. And he walked you through that. And that's, again, I do believe for FPGA deployment or HDL when you code generate from the Simulink. And then there's this powerful little demo here. Basically, we knew this. You could take this Kalman M function and drop it into a Simulink model, and then use the MATLAB M function within the Simulink model. Now, that is very cool, but on top of that, there's two other advantages. I showed this as part of my other video last week. You can take your Simulink model and you can generate, let's say this is the Kalman filter, you can generate or build a custom M function and embed it into a Simulink model. This is an example here using this Kalman. And then finally, once you build your model in Simulink, you can co-generate it into C, C++, or HDL for FPGA deployment, again, for ultra lowest latency HFT. All right, so that's all explained in all of this. Now, I didn't even know this, as just for those that are using Simulink, there's this video viewer block in Simulink, which is now put instead of using a scope, and this allows you to watch the animation of the Kalman filter function that he shows in the original Matlab M function. So you can do that from within Simulink itself. I never knew that, but again, that's something very powerful. Now that takes me to the next point of FPGA and ultra lowest latency. I've shown videos and various discussions on this, and it's proven. I call him Mr. FPGA. He's done some videos on it, and if you want ultra lowest latency, this is the path to go. So this right here enables you from this point, take your trading idea via the MuPad or the Symbolic Math Toolbox, deploy, generate maybe some C, or generate a Matlab M function, drop it in your Simulink, and then finally be able to, it's a bit of a process, but to be able to generate either, as I said, your C, C++, or your HDL, which is your hardware description language, for your FPGA. I've shown that numerous times, but again, that's another world. And I say that because you have verification to ensure that what you generate in your code are that they match, and that's a whole other process. But again, I'm gonna leave it at this point to let maybe some other experts carry on with that one, which of course is this guy here. So I'm kind of blown away by this, and there's a bunch of takeaways from this day forward I can learn. You know, the numeric analysis might not be the smartest way to develop trading models, or even to look at the world of trading. And that's typically done through languages like R, Python, and then of course even toolboxes like financial or econometrics. So that's one thing I took away. So I'm going to probably pursue this methodology. On top of that, to be able to take these Matlab M functions that are generated through the MuPad and connect them into the Matlab workspace environment, you can then of course generate your C functions from that. And then again, if you choose already in C, or go the HDL route, because you can deploy them into your Simulink. So where does that leave all my current stuff with the plumbing for the custom trading platform? The powerful thing is once you have your C DLL or your C, and that's most likely cross-platform, meaning let's say if I do this in Windows and I just go as far as to generating C, I can then take that C function or library and then be able to use that library as for a potential trading platform within Linux. That's using obviously the GCC and whatnot. So that's one big example. Or again, if I use OS 10 for Mac, and I can generate that from MATLAB again because MATLAB's cross-platform. It runs on Linux, Mac, Windows. It's all the major OSs. On top of that, the other powerful thing is, if we decide to go this route, and we decide, let's say at some point we want to go HFT, we could take these visual models, both from Simulink, Matlab, M functions, and then be able to take that visual representation from Simulink, and then through a workflow be able to bang out our HFT stuff for FPGA. Alright, so it's pretty well the same thing I've been saying for a while, but this type of way of building algorithms is becoming more, is coming more into the forefront versus the numerical analysis. And I just want to put this entire process together because it's really got my wheels churning, and wheels in my little beady head turning, I should say. So I thought I'd just point that out, put this video together, and just say, hey, this could be a pivotal moment right now. And let me know what you think. Talk to you later.